Hi, thanks for joining me for the GISP test prep class. This class is chock full of information that helps you pass the exam. Like we have to start talking about, we have to start at the beginning. What is a point? What is a line? What is a polygon? What are the vertices that make up a polygon? What's a node? What's a dangling node? Where are those vertices stored? They're stored in the shape field. What's a shape field? It's a field in an object-oriented database. It's a blob field. What's a blob field? So we have a lot to talk about, and I find it really hard to fit all that content into 3 days. So to help us out a little bit in the class, I've recorded this introduction and the first chapter, which is sort of an overview of the GISP certification and a bit about how the exam is delivered. I've recorded that so that we can get a quicker start into class on the first day. Okay, we can dive right into the actual content for the exam. But now that I've said that, don't stop this recording, because you need to watch this, because there are some things there will likely be some things on the exam that are covered in this chapter. Okay, and I'll point them out when we get to them. All right, so thanks for watching. My name is Jenny Harrison. I'm the owner of TeachMeGIS, and I'm also an instructor. So you can reach me at this email address. All of our GISP courses are recorded, and the recordings are available to the students up until the week of the exam. So you can watch the video as much as you like before the exam time. Many of our students make use of these and watch them over and over to really get these concepts cemented in their heads. Also, we have a free retake policy. If you choose, maybe you make a decision, you change your mind, you don't want to take the test this next test time, you can always come back next year, like next season. Let's say you decide not to take it in the fall, but you're going to take it in the spring. Well, you can come back in the spring and resit the class for no charge. Now, I have to say up front, this class cannot guarantee you pass the exam. This is not the sort of exam where you just memorize a few terms and a few facts and you walk in and pass it. It truly is an exam that tests an entire career of knowledge. Okay, this is like becoming an engineer or an architect. It's not going to test you on your software skills. Do you know where to find the buffer tool in ArcMap? That's not what it's about. It's testing your industry knowledge. Okay, so you cannot just sit through this class and walk in and take the test. You're gonna have to commit some time to studying. And some people have even found that after taking the class, they need to go take a Python class or a class on projections. And if they've never had any experience in those fields, a third one that people often need is a class in remote sensing or image analysis in order to pass the test. Now, there's lots of free resources online. We offer courses here at TeachMeGIS, and community colleges offer courses. So somehow, if you've never worked with scripting or remote sensing or coordinate systems, you got to get that experience before you walk in for the exam. Okay, so let's talk about we're based in Houston, Texas, in the US, down here, but we have students come from all over the world because this class is offered virtually. And if you have a bunch of people, like we recently had a group from Italy who needed a class in their time zone. If you get 8 or 10 people together in your time zone, we'll offer it at a time that fits you guys. Okay, so reach out to me if you'd like to see this course offered in your region, either in person when COVID is over or virtually in your time zone. Okay, so let's talk about what's going to be covered in this course. The exam is divided up into 45 different knowledge areas about the geospatial world, and they're grouped into 10 categories. So we've taken that information, divided it up into about 12 chapters. So we're going to start with this chapter that's in the recording, the GISP Certification Overview. And then we'll get into, in the first day of the course, we'll jump right into industry standards. So in here, we're going to talk about OGC standards and FGDC standards, not only for metadata, but for file types, like the fact that the KML is an OGC standard. Okay, so we want to talk about things that are very important in the industry, but not every GISer has to think about every day. So help you have an idea what kind of bits you need to know for the exam. In chapter 3, we'll get really deep into coordinates, understanding the geoid, the spheroid, the set of datums, the set of projected coordinate systems that sit on top of a datum, and what are some of the properties of some of these projected coordinate systems, like what are the coordinate systems that sit behind the U.S. state plane coordinate projected coordinate systems? What are the projections that sit behind those state plane coordinate systems? I'll get it right in a minute. We'll talk, so all about projections and datums, really understanding those so that you can answer the questions on the exam. And then in chapter 4, we will discuss some basic science of the earth, understanding the structure of the earth from the plate tectonics and a bit of geomorphology and fault systems. So basic geometry and geomorphology of the earth. The very basic level, kind of geomorphology 101, or even much lighter than that. Just a little bit you'll need to know for the exam. Like, for example, about the Mid-Atlantic Ridge, we need to understand what that thing is and what a subduction zone is when two plates crash together. Okay, you don't have to be a geologist, but you got to know some basics. Chapter 5 is cartography and visualization. Most GISers are pretty good at this, but we just want to talk about a couple of rules that maybe you haven't heard before. For example, how do you make a map that is suitable for people who may have color blindness issues? And how many font families should you pick for a map? And what is a serif versus a sans serif font? And when should you use one or the other? Right, so we'll talk about basics of symbolization and fonts and just getting a good cartographic product out of GIS. In chapter 6, we'll get into GIS file types. We'll talk about what are OGC standards. We'll talk about file-based data like shapefiles and geodatabases and KML files and GML files, but we'll also talk about web services, understanding REST services and SOAP, and what sort of files, what's the difference between a web map service and a web feature service, and what a tile service is. So all the stuff around how we store GIS data. Chapter 7 is data acquisition. How do we get data into our GIS, like georeferencing, but also collecting data with a GPS. So we need to understand the issues around GPS data collection. What are the different types of GPS receivers we can purchase? What kind of signals do they receive? What causes noise in collecting GPS data? What is a signal to noise ratio? So we'll get kind of deep into GPS and also drones, drone data collection. Now you don't have to be a drone pilot, but you have to know some basic things about drones. And like, for example, what are some of the rules around flying drones? Okay, so these are the topics that we cover in chapter 7. And then in chapter 8, we get into the analytical method. So in here, we talk about the kind of geoprocessing tools you may have seen in our GIS Pro or ArcMap, buffer, clip, union, intersect, the concept of Boolean overlays, and Boolean logic in overlay analysis. But we also get into some more mathematical statistics like root mean square error and standard deviation and correlation coefficients. Okay, so that's the math chapter in chapter 8. In chapter 9, we talk about raster processing and analysis. So in here, we'll look at raster math with the raster calculator. So overlaying data sets, overlaying rasters to do least cost path analysis or site investigation, site selection. So really about the raster calculator. And we also talk a lot about how rasters are stored. Chapter 10 is database design and management. You don't have to be a DBA to pass this exam, but you have to know kind of database 101 stuff. Some basic terminology around databases, like what is a view and what is a role, and how do we use roles to control permissions on a database? How do table joins work, and what's the difference between a join and a relate? Chapter 10, so that's chapter 10. Again, don't have to be a DBA. but you got to know kind of database 101. Chapter 11 is scripting and application development. So in here we look at pseudocode and basic Python, talk a little bit about the difference between a script and a program or an application, and a little about graphical modeling or model builder. Now, I can't teach you these subjects in this small amount of time. We have a whole 2-day model builder class, and like I said, 3 days of Python, along with another 2 days if you want to learn the Python API. So scripting and application development is something you need to have a little bit of experience with before you come in the exam. And I really recommend trying to find a little programming class if you've never taken one. Chapter 12 is systems design and management, the IT side of GIS. Like databases, you don't have to be a system administrator to pass the exam, but you need to know a few things like some basic terminology. What is a virtual machine? What is a VPN connection? What is a database server versus an application server? So yeah, a little bit of IT stuff in chapter 12. And that's it. Chapter 13 is just kind of a wrap up. So that's the plan for the course. All right, but we're going to get into chapter 1 in this video, the GISP certification overview. So let's look at chapter 1. In chapter 1, we look at the GISP certification process in general and a little about how the exam is delivered. So the purpose of the GISP certification, what is a GIS? We think we all know, but let's just define it to be sure. GISP certification process and requirements, how the exam is delivered and scored, and then a little about your responsibilities to the geospatial professional practice important for your efforts to become a GISP, but also things that you have to do to maintain that GISP after receiving it. But first, the purpose of the GISP certification. I want to make sure that you understand what a certification is versus like a licensure or an accreditation or a degree or certificate. And I want to remind you again, these are things that may be on the exam. So you might get one question about making sure you understand what the GISP certification actually means, okay? So we'll pay close attention here. So some terms that are often confused with a certification are licensure. In the US, a licensure is an official and legal designation, allowing one to practice a profession, often regulated at the state level here in the US. It usually requires a degree or a certificate and the passing of a test. So doctors, lawyers, engineers, CPAs, and even real estate agents have licenses. Those things are overseen by the government. An accreditation is a designation given to the programs of an academic institution based on predefined criteria. For example, the nursing program, the nursing degree program at Murray State University is accredited by the Commission on Collegiate Nursing Education. So an accreditation is not given to a person, it's given to a program at a school or an institution. And then a degree or a certificate is a verification of having successfully completed an academic or training program, a PhD in geodetic science, an associate's degree in GIS, or a graduate certificate in GIS, or a certificate of completion in one of the TeachMeGIS training programs. Okay, but a certification is a process, often voluntary, by which individuals who have demonstrated a level of expertise in the profession are identified to the public and to other stakeholders by a third party. It's designed to recognize expertise in the industry. So it's not saying I have taken a class, it's saying I've worked in this industry and I know what I'm doing. Esri Desktop Associate, Microsoft Certified Professional, and GISP are all examples of certifications. In 1999, wait a minute, let me back up. So the point is that there's a third-party organization who recognizes these people, and that's the GIS Certification Institute, GISCI. In 1999, the ERISA organization here in the US, the Urban and Regional Information Systems Association, formed a committee to explore GIS certification within the profession and society. So this is way back in 1999. This work led to the creation of the GIS Certification Institute. The important thing is it's an independent institute supported by representatives from national and international GIS professional organizations. So it's not a company, it's a nonprofit, third-party organization. They don't do anything except GIS certifications, right? They don't offer GIS consulting services, for example. So they're completely impartial. As of 2020, there are over 10,500 people across the globe who have the GISP certification. And the nice thing is there's a GISCI website with a search tool on it to confirm one's GISP status. So if you apply for a job, your potential employer can go out to this website, search for your name, and make sure that in fact you are certified. So the certifying entity, again, is the GIS Certification Institute. It's a nonprofit with a specific responsibility of providing the GIS community with an internationally recognized certification program. It's a third-party organization. Some of its member organizations are listed here. So it was not just ERISA who did this on their own. They pulled together many of the very well-known organizations around the globe to create this GIS Certification Institute. And I mention them here. You don't need to, I mention them not because you need to memorize these groups for the exam, but I mention them because they're very good organizations to become a member of, to help get your contributions to the community as well as your education points for your initial GIS certification, GISP certification, as well as for continuing your certification once you pass the exam. So be sure to look up these organizations and try to become a part of them. It's a great group of people, great to know and great to have as a resource when you have a GIS question. A lot of knowledge sharing goes on in these organizations. All right, so let's talk about what is GIS and who is a GIS specialist, right? So I think we all know GIS stands for Geographic Information Systems, but in the industry, there's some confusion about who we actually are as a people. So we often get confused with surveyors, mappers, photogrammetrists, and CAD specialists. So let's define those terms, okay? And again, this is fair game for the exam. So there may be something on the exam like, a surveyor differs from a GIS specialist in what way, right? So that's why we mention them here. So surveyors, what they do is they determine the exact position of features and the angles and distances between them. Okay, so they go out in the field and they measure exact locations of things, properties, roads, bridges. Surveyors may also gather some attributes as they collect the locations. They might, for example, collect the time of day or some information about the property, and that's normal and that's okay. But GIS is different. And of course, guys, if you are a surveyor, a mapper, photogrammetrist, I'm not at all trying to give a complete description of what you guys do, because I know you do a ton of stuff. I'm just trying to give you the high level of what might be pulled out on the exam, okay? So a mapper, and people using visualization software like Google Earth or Google Maps, they create visual representations of real world locations and expose that data spatially through thematic mapping techniques. A thematic map, by the way, that's a term you need to know for the exam. A thematic map is a map where the layers are color-coded by some theme, like color-coding the roads by speed limit or the lakes by the sediment load. Right? Color coding on a numeric or a text field makes a thematic map. So anyway, a mapper, also called a cartographer, right? They show location and attributes. Mappers can display X, Y, Z, time, and attributes, but they are still different from GISers. Photogrammetrists, now they're a special group too. They deduce positions of features and the angles and distances between them. by measuring from photographs. Photogrammetrists may also analyze the data to determine attributes like land cover. So photogrammetrists can determine XYZ time and some attributes. And a subset of photogrammetrists are called image analysts, right? Image analysts look at aerial photos and satellite images and interpret what's on the ground. But again, they're different from GISers. Now, GISers may perform some of all of these duties too. And surveyors and mappers and photogrammetrists may do some GIS, but the distinction is going to be here just in a minute. Let's talk about one more group of people, computer-aided drafters. That's a special subset of mappers that use CAD software, computer-aided drafting software like AutoCAD or MicroStation, to create detailed plans for structures like buildings and bridges and drilling platforms down to the type of screw that holds these platforms together. But they also map large areas like entire subdivisions or whole cities. CAD software does allow for the capture of some attributes, but most of the attributes are stored in a way that relate to the color or the thickness or the type of symbol that should be used, like line thickness. CAD files may or may not be spatially referenced. They could be drawn in page units, but nowadays they're often drawn in projected units, just like GIS. But what makes it different? The thing that makes GIS different is that GIS adds analysis into the mapping and the data collection, okay? GIS allows for the collection, storing, display, and analysis of locations. Of locations, time, and attributes, okay? So the difference with GIS and surveying, mapping, photogrammetry, and drafting is that GIS can do that really cool spatial analysis. It can also do temporal analysis. If you see that on the exam, that's analyzing features over time, looking at an aerial photo from last year and this year and seeing what's changed. Okay, so if there's a question on an exam about what you need, how does GIS differ? GIS is the one that does analysis. By the way, a GIS specialist is someone skilled in the analysis of geospatial data and in all aspects of geomatics. So you need to know that term, geomatics, and its definition might be on the exam. If I haven't said this yet, the exam is multiple choice. It's never short answer, right? So you're not going to have to come up with the word geomatics, but you may have to pick it out of a list. So let's see what does geomatics actually mean. Geomatics is the mathematics of the earth. It's a scientific term for gathering, storing, processing, and delivering geographic information that describe the earth. In addition, it's an umbrella term for every method and tool from data acquisition to distribution, including math, computers, and earth science. So everything we do in GIS falls under the umbrella of geomatics. So I went a little overboard here with this definition that I've added in here from Wikipedia, but you just need to know geomatics is the mathematics of the earth, and it's the umbrella term for all the things we do in GIS. I do have a note here, I forgot this. You do need to review this Wikipedia page and know what disciplines are included in the umbrella term of geomatics, because you'll find that the other terms that we talked about, surveyors and photogrammetrists, right? They also do some geomatics. So review that page. Okay, so let's talk about the GISP certification process and requirements. Be sure to refer to the GISCI Core Technical Knowledge Exam Candidate Manual to read all the details about preparing for the exam. The GISP certification involves, now this is just the certification, not the exam alone, right? The GISP certification involves accomplishments in 3 areas: educational achievement, professional experience, and contributions to the profession. This is something that goes way beyond the responsibilities of your employer This is your commitment to the field, okay? So you're taking this on yourself. The educational achievement means college or university education, or that's okay if you didn't, if you don't have a college degree, that's okay too. Continuing education, professional development courses, attending conferences and webinars, all of those things count toward your educational achievement points. So you start this portfolio, right? And you have to submit all the things you've done toward education, and you get points for each one. Just to give you an idea, like 40 hours of training gives you 1 point, right? So you can get portions of a point. If you take a 2-hour workshop, that counts as some decimal part of a point. So don't forget anything, right? And you can go all the way back as long as you can remember and have evidence to get these points. And the GISCI, they're really understanding people. If, you know, they will accept almost anything reasonable to verify your educational achievements. I think one time someone submitted like a scanned copy of a conference badge to show they went to the conference, or sometimes just a receipt showing that you were registered and you paid. So talk to them. If you say, well, I got my degree back in 1993, but I lost my degree or whatever. I lost the paper. Talk to them and see what you can do to get proof, right? You also get points for professional experience. That's your years of experience using GIS in a professional position outside of school, okay? So it doesn't start counting until you finish your school. Well, now that's not true. If you're working, doing GIS full-time and going to school part-time, those full-time points count. But you can't get points for class or graduate assistant work, for example. You get different points allotted depending on your job title and role. So if you're full-time GIS, you get a certain number of points. But let's say you are an engineer and you do GIS about 20% of your time, then you get a different set of points for that GIS experience. Regardless of points, you have to have a minimum of 4 years of experience outside of a school setting. You also get points for contributions to the profession. That means being involved in a professional association or GIS volunteer efforts, presenting at conferences, submitting maps to map galleries, writing an article. Even something like here in the US, our kids start learning world geography in 6th grade when they're about 12 years old. I know some colleagues have gone to give talks at 6th grade. Their kids' classroom talked about GIS, and they get points for that. Okay, so if your company does not give you time off to go attend conferences, that's okay. You can still get contributions to the profession by volunteering, but you need to seek out ways to volunteer. There are volunteer efforts here in Texas where I live. We have the Texas EGRET organization. It's the Emergency GIS Response Team. We go out and help people in small rural areas. There's a flood or a fire and they don't have a GIS presence in the command center. Volunteers show up and set up a GIS with a projector and a plotter. There's the GIS Corps. That's an international volunteer organization that lets you do stuff from home. Like when the hurricane hit Puerto Rico a few years ago, we got online onto a shared site and reviewed aerial photos of the island, looking for places where trees had fallen over the road. And we flagged those photos so that local first responders would know they need to bring saws with them when they go out in that area, right? So look around for ways to volunteer in the GIS world if your organization does not let you attend conferences. Okay, again, reach out to the GISCI or do some Google searches if you need some help, and email me. Okay, so how do you get certified? Well, to get certified, to be awarded as a GISP, to be awarded a GISP certification, you must have those 4 years equivalent full-time geospatial experience. You have to submit and get a successful review of your GISP certification application portfolio. That's the thing that documents all of your educational points, your professional experience points, and your contribution to the profession. And then you have to take and pass the GIS-CI Geospatial Core Technical Knowledge Exam, also known as the GISP test. You must complete all requirements within 6 years from the start of the application process, but you don't have to complete them in the above order. You can start with submitting the portfolio or start by taking the test. A lot of people nowadays, new GISers just coming out of school, are starting their GISP certification process right out of school. So beginning their portfolio, and over the 6 years, or let's say 4 years when they're out of school, they submit all of their documentation. Once you get certified, it's valid for 3 years. Recertification is done through just an online application where you go in and verify that you've had at least 6 educational points over those 3 years, 6 contributions to the profession, and 12 other points. And if you've been working, you can get work experience. You can get those 12 points from work experience. But let's say you've taken time off from work for one reason or another. Well, you don't have to have work experience points. You can do more contributions to the profession or get more educational points. And again, those educational points come from taking classes like TeachMeGIS classes or community college or university, continuing education, or even online courses that you get some kind of certificate and you can prove that you attended. You also get educational points for conferences, attending conferences. If you let your certification lapse for more than a year, you'll be required to resubmit your application and portfolio and take the exam again. So be careful. Don't let your certification lapse. I do think there's a buffer year in there, like a grace period, but watch it closely, okay? So this means you need to keep up with your education and contribution points because it'll be hard to get them all in 1 year. Right, so just two of each a year, and you'll be good. Well, 4 of the additional points from any category. Keep all your documentation from everything you attend. Okay, so let's talk about the exam. The exam, I want you to know that the exam questions were not just pulled out of the air, and it wasn't just a bunch of us older GIS guys sitting in a room thinking, what are the hardest questions we can think of? I personally was not involved in the exam creation at all. Okay, I'm not involved with GIS-CI directly, other than, I'm friends with them and I am a GISP, but I was not involved in the making of this exam or the planning of this whole certification. But I do know that it wasn't just a bunch of people getting together in a room. They based the exam, the knowledge areas, on the U.S. Department of Labor Geospatial Technology Competency Model. Okay, the U.S. Department of Labor has competency models for a whole bunch of different industries and a bunch of jobs, right? And so the GIS-CI based this exam on what the U.S. government expects of a GIS professional with about 4 years of experience. So it's not a software test, it's software agnostic. It's a true test of your understanding of the geospatial field and not a test of memorized facts. And I know you can't really see this, probably can't see this model very good, but you can look it up at this link down here. But what's important about this pyramid of knowledge is that there's a lot more on here besides just really understanding the geospatial side of the world. You've got to understand math and statistics and how to write intelligently, and interpersonal skills and management competencies. So all of that stuff is in the Department of Labor Technology Competency Model. But again, the bit that's on the exam is what was expected, according to U.S. government, expected of someone with about 4 years of experience. Now, the test is not specifically for the U.S. It's the same exam is offered all around the world. But because it was developed here, there are a few things that are specific to the U.S., and I'm going to help you with those, okay? That's things like U.S. federal government standards for map accuracy, for example. Just a few things, but I'll point them out. That Department of Labor geospatial technology competency model from the US government is complemented by the University Consortium for Geographic Information Science body of knowledge. So the University Consortium has these bodies of knowledge, these massive documents that list every little tidbit of knowledge that a student should have if they're passing through a particular program in the university system in the US, really. So if you're going to be a GIS professional and you're going to have a class in data modeling, well, there are a bunch of topics that should be covered in any university data modeling program. Okay, so this GIS and T body of knowledge is used by professors when they're developing curricula for a class, either training manuals, training books, or a syllabus for a class, right? Now, you don't need to go study this body of knowledge. It's, I don't know, like 90 pages or something. But I'm telling you this because I want you to know, again, the questions weren't just pulled out of the air. They're based on the Department of Labor's standard, the geospatial technology competency, and this GIS and T body of knowledge. Okay, but don't feel you have to go study this whole thing, because there's a bunch of stuff in this body of knowledge that's not tested. It's comprehensive. Like if you want to get a PhD in geodetics, that stuff's going to be in the body of knowledge. You don't need to be a PhD in geodetics to pass this exam. Okay, so this is just here to tell you the exam, they put a lot of thought and a lot of work into creating this exam. And they pulled it from really good sources, not just made it up. Okay, the exam has between 175 and 190 selected response questions. That means they're either multiple choice or multiple response answers. A multiple choice is where you have like 4 options and you have to select the one best answer. A multiple response means select all of the correct answers. Okay, you might have 4 options and it's going to say select all that apply. Just a little note, anything that says select all that apply will always have at least 2 answers. Okay, never just one. So keep that in mind for the exam. Anyway, out of these 175 to 190 selected response questions, only 100 of them are scored. The others are being evaluated for future exams, because what happens is GIS-CI has to have this huge bucket full of questions so that everyone who walks in gets a random sample of those questions. And the 2 people can take the same exam on exactly the same day, sitting at desks next to each other, and get completely different questions. But they're all being pulled from that library of of questions. So, and then every year, some of the questions have to be retired and new ones have to be added in. That's both to keep the exam timely and up to date as new information comes out, but also to make sure that the integrity of the exam stays intact, that someone doesn't go in and memorize all the questions and then go sell those questions, right? So, yeah, so questions are constantly being retired and added. And because of that, there are some sample questions on the exam that don't get scored. The problem is you don't get to know which ones are being scored and which ones are not. So you have to put the same effort into all 175 to 190 of the questions. But it also means don't get too discouraged if there's a whole topic there that you're not really familiar with. They might be sample questions for a later exam. So again, they're multiple choice or multiple response. Pay close attention to whether the question says select the one best answer, or it says select all of the correct answers. Okay, there'll be at least 2. Notice this select the one best answer. That's a very important note. Select the one best answer. Because sometimes a question will have like 4 answers and the first 2 sound pretty good, but it might be the 3rd one sounds just as good and has some more specific information, right? So, you know, if the question is, which geometry type can be used to store the location of a lake? And the answer is point or line. Well, wait a minute. You could store the position of a lake as a point. Like if you're zoomed out to the whole world and you just want to know generally where lakes are, they might be points. But then answer B might say lines. And it's true, you could store a lake as a line. We don't normally, unless we're trying to store something about the shoreline of the lake, like this bit's sandy and this bit's marshy. So then answer C might be polygon. So polygon is the best answer. That's the normal way we display lakes in a GIS, right? So be sure to read all the answers and find the absolute best one. Don't stop reading on A or B if you think it's right. Check the others just to be sure. Every question, very importantly, is either correct or incorrect. So even if it says select all of the correct answers and you picked two, but you picked A and B, but the answer was A, B, and C, you don't get any partial credit for finding A and B. It's either completely correct or not correct. You get 4 hours for the exam. You can't take any, the exam is given at a testing center and you can't take anything in the room with you. They will give you a simple calculator, maybe on the screen, and a pencil and paper or a little whiteboard, something where you can make sketches and on. The exam is always given in English. So you have 45 different knowledge areas on the exam, grouped into those 10 categories I told you about. Those 10 categories are listed here on page 1-22 in your book. I'm not going to read through all of them, but I wanted you to notice that the categories are not weighted the same. What I mean is that the geospatial data fundamentals, it is the most important concept on the exam. And so however many of those questions you get correct, that's 15% of your grade. Okay, so it doesn't mean you'll have 15 questions from this section, but it means that your score on this set of questions is worth 15% of your grade. And the questions are not grouped by knowledge area. They're all mixed up on the exam. So you won't necessarily know which question went to which knowledge area. You don't have to worry about it like that, but we're just saying that they tried to say things like systems design and management, has a much lower weight. You still have to know a little bit about it, but it's not as important as geospatial data fundamentals. Each one of these knowledge areas, each of these 10 knowledge areas, of course, has a bunch of subcategories. I'm sorry, each of these 10 categories are broken into 45 knowledge areas. Each of the knowledge areas have subcategories. So you get 73% as a weighted average is a passing grade. Very important to note, 72.9 is not a passing grade, okay? They don't round. It used to be you had to get a 75 to pass, but now they've changed it to 73, but they don't round at all, okay? So it's got to be 73.0 or higher. So just as an example of this weighted average, you can look here on page 1-23. Suppose these are your 10 groups, your categories, and suppose you had 10 questions from each one for a total of 100 questions. And suppose this column shows you how many questions you actually got correct in each section. So if you notice, this person did really well in almost all the groups and got all 10 questions correct, but they did really poorly in sections 2, 4, and 5. 2, 4, and 5, if we look back, 2, 4, and 5 are pretty important areas. So they did kind of poorly in 2, 4, and 5. So if I just added up the number of correct, I would get a 75. Seems like I passed. But if I do the weighted average, right? The number of correct divided by the number of questions times the weight. Then I get a 69.3 and I fail. Okay, so anyway, that's how it's scored. If you don't pass, you'll be told what areas you were weak in, but I don't think you see the actual score, the actual number correct in each section. Okay, so 73, that's what we got to get, guys. The exam is offered over several days in the mid-year and in June, and again over several days at the end of the year in December at a PSI testing center, and they're all over the globe. You check the GISCI website for a list of these PSI testing centers and the current exam fees and the upcoming exam dates. So again, you can't take the test sitting at your office or at your house online. You have to physically go to a testing center, a secure testing center, to take the exam, but you can register online. Be sure to review the official exam candidate manual and the exam preparation info page of the GISCI website before you go in to take the exam. But way before, right? In your process of preparing for the exam. It's important to note that they close registrations for the exam 2 weeks before it starts. So make sure you register early. You can't make a last minute decision and go in and take the test. 2 weeks early. Something that's really great that's happened in the past year is GISCI has released an official practice exam. This is an awesome resource that guys who took the exam before didn't have. This is 50 questions that have been retired from the exam. They're written in the language used by the exam, which really helps you get familiar with how the test is going to look. It's a 50-minute online exam. There's a small fee to take it. Today, on the day of this recording, which is in September of 2021, the fee is $30, 30 US dollars, at least for us in the US. But you can take it twice for that one fee. If you go take that practice exam and you get like a 50% on it, you're probably not ready to go take the main exam. Okay, you probably need to study a little bit more. If you take the practice exam and get like a 90%, you're probably ready. Now, but taking that practice exam does not guarantee you're going to pass the test. And if you get a 90% on the practice exam, don't stop studying, right? Because that's only 50 questions. You can't know everything that's going to be on the final exam using the practice one. But it's a really good chance for you to understand where you are in terms of preparation for the exam. And if you're taking this class, I'd wait. Don't take the practice exam yet. Take the class first, learn what's on it, learn the kind of things that are going to be on the exam, and then go take the practice exam. It gives you a score plus detailed feedback on each of your responses, along with the correct answer, so you'll know what you did wrong. It can show where your weak areas are. And this is a disclaimer directly from GISCI, making sure you understand that just because you pass the practice exam, it doesn't necessarily mean you're going to pass the final exam, but it's a good indication of where you're strong or weak. So be sure to sign up for that. This is a great opportunity. Okay, so that's about it for the GIS certification and how the exam is delivered. Let's just talk a little bit about your responsibilities to the geospatial professional practice. Page 1-28, if you're following along on your exam, the GIS certification, GISP certification is certifying that you not only know your stuff, you know your geospatial stuff, but it also obligates you to committing to a certain code of ethics in your life and in your work life. Hopefully in your personal life too, but in your work life for sure. The guidelines provided by a professional organization like GISCI is to help you make professional ethical decisions is called a code of ethics. A code of ethics are things like how's data collected, how's it used, how's it presented. The GISCI has a set of a code of ethics out here on their website, and you should read it. Because this code of ethics is fair game for an exam question. They may ask you something on the exam to make sure that you've read that thing and that you agree to it. Okay. For example, the GISCI code of ethics consists your obligations as a GIS professional to society, to employers and funders, to colleagues and to the profession, and even obligations to individuals in a society. And there may be a question like the code of ethics gives, as a GIS professional, you have obligations to what 4 groups of people. There may be something about how does conflict detection, conflict resolution work in the code of ethics. So you need to read that thing. By the way, for you guys who are taking the class, you should receive from me before class a Word document that's got all these hyperlinks in it. So all the links you see in the presentation, you'll have them in a Word document, as well as the hard copy. I mean, you'll have the hard copy training manual. You'll get that in the mail, of course, but you don't have to type out all these links. They'll be available in a Word document. Also in the class, if we go back to the test, in the class, we go into breakout rooms. Like in the last class I taught last week, we had about 30 people in the class. At the beginning of each chapter, we break out into breakout rooms with 4 or 5 people in each room, and we go over some sample questions from the exam. They're not really from the exam. There's some I've made up and some from an original set of questions delivered, shared by GISCI. But anyway, there's sample questions around some of the topics that are on the exam. And it's a great opportunity because in that room last week, we had 30 of some of the best GIS brains in the country and some from international who were sharing their knowledge of GIS. So we almost always have somebody in the room who's a drone pilot, somebody who's a geodetics expert, somebody who's really good at cartography. And we learn from each other in these breakout rooms. Okay, so don't forget, read the Code of Ethics. So being a GIS professional is more than just knowing how to use a GIS software. It's an understanding of appropriate interpretation of work-related policies and procedures, understanding of ethics related to technical GIS work, knowledge of managing, documenting, and communicating GIS work, awareness of how GIS is used across other professions, and awareness of and contributions to GIS-related professional organizations. So you really are committing to a whole professional environment. You're not just taking a test to get a credential to put on your desk or put in your signature line on your emails. The founding organizations are listed here again on page 1-30. I mentioned them at the beginning of the chapter. I just want to throw them in here again because they really are good organizations to be a part of. I've been involved in most of these except, well, I don't need to mention which ones, but I've been involved in most of these and they're all really good people and such great opportunities to be in the room with other GIS professionals at these conferences. And you get contribution points for being parts of these organizations. I need to mention, if the professional organization is not specifically GIS, you might still get points for it. Like I had someone in class who worked for a utility company, and he attended a conference specifically about electric utilities. It wasn't a GIS conference. It was a conference about utilities, but he was the GIS professional for this electric company. So that stuff that he learned at that conference related to his job, and his job was GIS. And so he got points for attending that conference. So when in doubt, ask the GISCI guys and ladies, can I get points for this? Don't be shy. I think the term they told me is we're not the GIS police or something like that. They're trying to help you get your certification, but you got to be honest and you got to be sincere about what you're doing. GIS is not confined to a single industry, by the way. So on the exam, you may see questions related to police, fire, emergency response, geology, petroleum, environmental. Anyway, you won't have to be a specialist from one of these industries, but the story questions might be related to one of these industries. And so all of the answers should be things you can think through just on your knowledge of life and think through the problems related to the points, lines, and polygons in the GIS. So you don't have to be an archaeologist, but don't be surprised if there's a question, something about, I'm gonna map out the polygons in this archaeologic site in Western Kentucky. What should I consider before I start capturing the polygons? And maybe it's what coordinate system are you using? A Kentucky State Plane coordinate system, or so things like that. It'll be GIS questions, but in the story they may involve any industry. Okay, just a couple of things just to help you start thinking about like your obligation to the people when you're doing GIS, right? And your ethics. You need to understand some of the rules around GIS. Like, for example, here in the US, we have the Health Insurance Portability and Accountability Act. The word act is sitting under that little symbol. Act of 1996. Privacy Act. What did I do? HIPAA. Okay. Health Insurance Portability and Accountability Act. It's called HIPAA here in the US, and it controls how we have to secure all individuals' medical records so they don't end up online. And so as a GIS professional, if I'm a consultant and I get a job working for a clinic, and that clinic asks me, can you make a map of all of our patients and where they live? We need to know enough to say, I cannot make that map for you unless you guarantee me it's not going to get outside of your hands, right? We don't want to make a map that shows all of our, well, you can make it for your boss, right? And keep it secure, but you got to mark it as, you know, secure and should not leave this individual's hands or whatever. You don't want to just make a map for a conference and go put a poster up in a map competition showing everybody's house and what illness they have. Right? That violates HIPAA laws. So the point is you have to understand some things outside of GIS to work appropriately and to be a GIS professional. But anyway, know that understand HIPAA compliance in the US. It just means you can never identify a person, where they live and what their medical conditions are, and make that available to the public without that person's written consent. Okay, and we'll see how this affects us later in the course when we talk about like data aggregation. So rather than making a map of Houston showing where every person lives who has, let's say, I don't know, let's just say they have asthma. Rather than showing every person's house, I'll aggregate those occurrences maybe up to the neighborhood level or the zip code tract level, right? So over here on page 1-33, suppose you'll see an example. Suppose you have addresses of people who recently came into your clinic who were diagnosed with skin cancer. You want to map the prevalence of skin cancer in the city as it compared to the geographic extent of some skin cancer awareness billboards. So when you say, oh, this neighborhood has a lot of skin cancer, let's do some more outreach in that neighborhood, okay? So the thing is, you must not plot each person's address. You can generalize the data to zip code or within a 5-mile buffer of the billboards. The generalizations must be broad enough to assure that an individual cannot be identified. So you might have, on the exam, you might have questions like, which of these violate HIPAA? Or you might have a question like, if I do this, what law will that violate? Or you might have a question like, which of these can I do and be safe, you know, be following all the rules in the US, right? So you might, the question, I don't know how they might exactly ask the question on the exam that you get, but you need to understand HIPAA means never identify an individual's home address and their medical condition together. I mean, that's how it affects us in mapping. It means also their work, or, you know, nothing on the map should tie to an individual person and their illness or their medical records at all. Okay, we'll talk more about it in class. By the way, a part of your responsibility as a GIS professional is to accurately document your data, especially if it's being shared outside of your organization, but even inside your organization. And that means by filling out metadata. So we'll spend some time in class talking about metadata and the requirements and the formats. Another part of documenting your data is creating a data dictionary. I don't know if you have that in your organization, but if not, you might want to start making one. A data dictionary is a document that explains the entire structure of your data. It's a bit more than just a data model. It because it explained, and oh, well, wait a minute, the data dictionary doesn't have to be a particular file type. It could be a SharePoint site, OneNote, Word, Excel, a website, a Teams site, whatever your organization works for you. I mean, whatever works for your organization. But it should be things like, what are the names of all my feature classes? Where did I get them? When did I get them? Inside that feature class, what attributes am I using? What are the units of measurement? Is that the depth of that well in meters or feet? What coordinate system is used? How often is the data updated? All of this stuff should go in the data dictionary. So it's more than metadata, and it's more than a data model. It's completely a complete description of your GIS. Okay, so you need to know about that as a part of your commitment to the field. Anyway, that is chapter 1, the purpose of the GISP certification. What is GIS? Remember, we talked about surveying versus mappers or cartographers versus drafters or CAD specialists versus photogrammetrists, image analysts, and GIS. We talked a little about the certification process and how the exam is delivered and scored, and a bit about your responsibilities to the geospatial professional practice. So thank you for watching this introduction before your class. I look forward to meeting you in class and really getting into the guts of the GIS profession, this profession we all chose for our lives. Okay, see you soon.